How to wire the thermostat XH W3001, working with direct current or direct current 12 volts. Hello dear internet friends, we have already made a tutorial on this kind of thermostat in 110 volts or 220 volts alternating current version. We are now going to do another step-by-step tutorial on how to assemble an XH W3001 thermostat that works with direct current for the main purpose of making an incubator for the artificial incubation of eggs. The thermostat operating with direct current is quite different from a thermostat in an alternating current version. The one that works with direct current should require the most attention when connecting the components of the incubator. It is imperative to pay attention to the level of polarity. In this tutorial, we will do our demonstration with the 12-volt battery, also knowing that it can optionally be replaced by an AC/DC adapter. An adapter consists of a plug to be connected to the 220-volt or 110-volt mains, then an outlet which provides a voltage of 12 volts direct current. We have the choice of using an adapter, solar panel or battery to operate our XH W3001 thermostat. So this is the real face of our XH W3001 thermostat. It is composed of 4 wires and the probe which are normally located at the back of the thermostat. At the level of the part where it is written and which means input in English, we have 2 red and black wires. The red wire is the positive terminal that plugs into the plus point of the battery or our 12-volt adapter. The black wire connects to the negative terminal of the battery. We will need to be vigilant when connecting to avoid damaging our components or even to ensure our own safety. At the level of the second part, it is marked output, which means output of DC current. This is a 12-volt direct current output that will be used to wire components essential to the manufacture of our incubator. For the rest of the assembly, we need dominoes or terminal blocks. They facilitate connectivity between components. As shown in the picture, we put the 2 wires of the current input and the others of the current output in the holes of the terminal block. We add here a battery which must power the thermostat or the incubator entirely. I repeat, you will have to be careful when plugging in because any mistake will destroy the thermostat. Mainly, I think you understand me, it is not a question of making the connection right away, but of locating and identifying the order of the wiring before taking action. It's not about plugging in a battery while you're editing. We notice at this stage that the incubator can start, but we will not be able to stop it if necessary, so we must think about it at this stage to remedy it. We are going to cut one of the 2 power input wires. I prefer to cut the red wire which carries the 12 volts instead of the black wire which carries the 0 volts. We place a switch in series with respect to the cut wire. We will now be able to turn the incubator on or off with our switch. We will now mount our incandescent bulb or our heating resistor. This element will be used to heat the incubator. Our heating element should have an operating voltage of 12 volts DC. But the best is to put an electrical resistance of 12 volts, I speak thus because in my home the incandescent bulbs with 12 volts are rare. I will give you some description of the link to buy a 12-volt electrical resistance for the manufacture of an incubator, the thermostat XH W3001 included. The bulb or resistor to be mounted has a positive terminal and a negative terminal. We must be careful because here we are in the presence of a direct current. So the plus of the bulb, red wire, connects to the plus of the thermostat output, yellow wire. The negative terminal of the resistor or bulb, black wire, connects to the black wire of the thermostat output. We will now add a 12-volt fan. Its role is to make the temperature homogeneous within the incubator. Ventilation and aeration are 2 different phenomena that should not be confused. Ventilation aims to renew the air within the incubator, while ventilation aims to standardize the temperature in all corners of the incubator. The same measures taken when fitting the bulb will be observed when fitting the fan. We place our fan in parallel with the 12-volt output of our thermostat W3001. We now have an incubator that can be started or stopped, which can provide fan-regulated heat to the system. However, at this point we will not be able to view the incubation status from the outside without opening the access door. We add another bulb within this incubator. But this bulb should not be incandescent. Its role will not be to heat the incubator but rather to provide the light necessary for viewing the interior background. The added bulb can for example be of the LED type, well known for its energy saving. Our added bulb does not have to be on at all times, so we have to act on our circuit. We are going to cut one of the two wires of the input current, just to place a switch to be able to control our bulb. We mount our switch in series with respect to the cut wire. This gives us the possibility to control the internal light of our incubator according to our will. The interior will be observed through a transparent glass, installed in an opening at the level of the main facade. Note that this bulb connects to the 12-volt input and not the 12-volt output. At this stage, we have a basic incubator that can fully play its role. But how can we ask the incubator to educate us on everything it performs as an operating instruction? We want to be informed without going near the incubator, whether it is on or not. We can sort of say, our incubator doesn't have eyes, so it's a blind incubator. We add a light preferably of a different color than the first one installed. Its good location is between the thermostat and the terminal block as shown in the picture. Thus we will be informed of all the actions of the output of our thermostat, consequently that of the resistance and the fan as well. We will do the same for our anterior viewing bulb. We place it parallel to our indicator as shown in the picture. At this stage our incubator is prettier, more interactive, more informative. We can get to work to build an incubator. But it would be good to make a more secure incubator. An incubator that can protect its circuit by itself in the event of a short circuit. It will therefore be necessary to think about taking the right solution. This requires adding a fuse, which in case of a short circuit will just blow its circuit to break the circuit and prevent any damage within the incubator. The fuse will be mounted in series with one of the input current wires. Since our incubator operates on direct current, I prefer to cut the red wire which is the 12-volt line to the detriment of the black wire which carries the 0 volts. The fuse will be mounted in series with one of the input current wires. Since our incubator operates on direct current, I prefer to cut the red wire which is the 12-volt line to the detriment of the black wire which carries the 0 volts. At the end of the process, you can get a control board that looks like this. From left to right you have the thermostat XH W3001. Fuse is the fuse that protects the circuit of your incubator. Main power is the main switch for turning the incubator on or off. Bulb is a bulb control switch used to view the incubator. MPV, main power viewer, indicator of the main power supply to start or stop the incubator. TOV, thermostat out viewer, thermostat output indicator light. For example, it lets you know whether the incubator's fan and heating are on or off. VV, viewer bulb, lets you know whether the bulb intended for indoor viewing is on or off. If it is a business incubator, for example, the company name, brand or contact of the manufacturer could be mentioned above. If you enjoyed this tutorial, please sign up to help us reach 1,000 subscribers, it will make us more motivated to produce new videos. You can also help our channel by liking or sharing the video. If you have questions, comments, you can post them in the comment section of the video. Those who can help us financially can do so by the ticket of our PayPal address in the description section.